Alright, I'm going to go over number 2, 4, and 5. We're learning about quadratics here, and all kinds of fun things that we're filling out and learning how to do. So, starting with number 2, we're given the standard form, y equals negative x squared plus 9. From the standard form, it's easy to find the y-intercept. To find the y-intercept, you set x equal to 0. Plug in 0 for x, and you end up with y equals negative 0 squared plus 9, which is just 9. So you get y is 9. And so our y-intercept is 0, 9. Then we can get factored form. By factoring this, I'm going to first factor out a negative. When you factor, it's nice to start with a make your leading coefficient positive. In this case, I have a negative x squared, so I'm going to factor out a negative, and I'm left with a positive x squared minus 9. I notice that x squared minus 9 is a difference of two squares, and so I factor it accordingly, and it's going to be x plus 3 times x minus 3. That's a shortcut to factoring that we studied back in Unit 2, and this type of factoring is factoring a difference of two squares. So if you need to brush up on that, go ahead and look at that in Unit 2 on factoring a difference of two squares. So that's our factored form. I'm going to write that over here. Alright, to find the roots, roots is another name for x-intercept. We also call it, sorry, I'm blanking here. It could be x-intercepts, roots. We also call them zeros. But to find them, you set y equal to 0 and solve for x. It's the opposite of finding the y-intercept. So if y is 0, then I get 0 is negative x plus 3 times x minus 3. And then you set each factor equal to 0, so x plus 3 is a factor, x minus 3 is a factor, and we end up with two answers. X is negative 3 and x is positive 3. My roots are negative 3 and positive 3. The actual x-intercepts that go with that, which are points, would be negative 3, 0 and positive 3, 0. I'm going to start graphing because we have 3 points already. We have our y-intercept and we have our two x-intercepts. So I put a point here at 3, 0. And one over here at negative 3, 0. Those are our two x-intercepts. And we have a y-intercept. Right here at 0, 9. Now when we study parabolas, parabolas are symmetric, and so there's this axis or line of symmetry, and that axis or line of symmetry happens right in between your two x-intercepts. So if I have an x-intercept at negative 3 and positive 3, I want to find, well, what number is right in between. Here it's pretty obvious, it's at 0, right? So the halfway mark is actually the y-intercept. I'll highlight it. So right here in green is my axis of symmetry. but in general you can find the middle of two numbers by averaging them. So if I took the -3 and added the +3 and divided by 2, that's how you average. You add the two numbers and divide by 2, we'd still get 0. And the line of symmetry is an equation of a line, a vertical line, and all equations of vertical lines are x equals, in this case, x equals 0. Now the vertex and the line of symmetry always share the same x values. The vertex is a point, and it's going to be at 0 something, and we actually have that. It's our Y-intercept is the vertex in this case, right? So if we drew this, we'd see that the vertex and the Y-intercept are the same. So it's important to interact with the picture as you find like the Y-intercept and the X-intercepts. Put them on the graph. Start thinking about like where's the middle of this graph? Where's that line of symmetry? How do I get the vertex, and so on. Now vertex form looks like this: y equals a x minus h squared plus k, where a here is the same, standard form. I'm going to write here, standard form is y equals ax squared plus bx plus c. And so a, we see in standard form, is the number in front of x squared, which in this case a would be -1. And so that's the same a for vertex form. So I know as I'm writing vertex form, I know I have a -1. That's where I'm getting the a from. And then x minus h. So h is your x value for the vertex. K is the y value for the vertex. So x minus 0 squared plus k. And so that would be vertex form. Now, x minus 0 is just x, and -1 times anything, so we could simplify this further to y equals -x squared plus 9. That would also be vertex form, which in this case is also standard form. So sometimes they match, sometimes they don't, but in this case they do. Okay, the domain is how many, from what x value to what x value is this going to be represented. And on the graph, it's going to go from -infinity to +infinity. So all real numbers. For the range, the highest value, or the maximum, is at 9. So we're thinking y values for the range. So domain, remembers x values. Range, we're talking about the y values. So the highest it goes is 9. The lowest it goes, well, -infinity. So it's everything below 9. It could also equal 9. So I'm going to say y is less than or equal to 9, or all y values less than or equal to 9. Where is this graph increasing or decreasing? When we talk about increasing or decreasing, we're talking about x values only. And half your graph will increase, half will decrease. And the way you tell is you read it or you trace it from left to right. And as you start tracing it from left, it's increasing until you get to the vertex. And then you hit the top, and then it's decreasing after the vertex, right? So it's increasing when x is less than 0. It's decreasing when x is greater than 0. We could also say when x is less than or equal to 0, or x is greater than or equal to 0. I'm okay with either one. And we want 5 points here. So 0, 9 is the center. got -3, 0, and we got a 3, 0, the X-intercepts. And I need a couple more points. To find the other points, I'm just going to plug in some values. So my equation is y equals -x² plus 9. And let's let x be 1. So if x is 1, then y is going to be -1² plus 9. Now it's not negative squared, it's just the 1 squared times the negative plus the 9. So it's going to be -1 plus 9, which is 8. So 1, 8. And then I'm going to use symmetry in the graph. If there's a point at 1, 8, there's going to be one over here, the same height, which would be at -1, 8. And you can test it out, but it'd work. And so you filled all that out, and we're done with number 2. Sometimes you have questions at the bottom here, and here I highlighted it, and make sure you answer those questions for your homework. It says, why is the graph of number 1 opening up and the graph of 2 opening down? And if you notice in number 2, a is negative, right? We've got -1. In number 1, a is +1, and it really depends on what a is. If a is greater than 0, which is a way of saying if it's positive, then the graph opens up. It's got this U shape. If a is negative, which means less than 0, then the graph opens down. Okay. All right. 3 we did in the notes. On to 4. On 4, I give you vertex form, and notice for vertex form, this could be rewritten as 1 times x minus 0 squared minus 25. And you can see the vertex a little bit better. You see that a is 1, h is 0, and k is -25. And so my vertex is 0, -25. Vertex form gives you the vertex right away. Also, the vertex, you can get the axis of symmetry, which is the x value of the vertex. So you want to know how all this stuff is related. And so the axis of symmetry is x equals 0. So that's the center of our graph. Also notice that a is positive. It tells us our graph is opening up. To go from vertex form to standard form, you multiply everything out. In this case, there's nothing to multiply out, so vertex form is standard form. And then from standard form, we can easily get the y-intercept. You set x equal to 0, plug in 0 into that equation, and you get your y equals -25. So 0, -25. So notice that the vertex and the y-intercept are the same. And then this is a difference of 2 squares. We could factor that to x plus 5 times x minus 5, and we have our vertex form. To find our zeros, which are the same as roots or the same as x-intercepts, you set y equal to 0 and solve for x. set each factor equal to 0. And we get two zeros, one at x equals -5 and one at x equals 5. Which means we get two x-intercepts, one at -5, 0, and one at +5, 0. So we have some points here, and so let's start graphing. So this one's 0, -25. If it gets to be a bigger number, like, you don't necessarily have to put all 25 tick marks. You could rescale it. You can count by fives to get to -25. Or if you had something like -152, you don't have to put a scale at all. Just put the point there and label it 0, -152. So when it gets to be bigger numbers, you don't have to put every tick mark in there, okay? I did in this case. I think I'm not going to take the time to count that's 25, but it looks like that, okay? So then our graph looks something like this. Careful that it's rounded, not a V shape. Our axis of symmetry is right down the middle here. I'll highlight that again. This cuts right down the middle here. And that's the equation x equals 0. So again, we have some points. We want a couple other points. So we got -5, 0. We got the center at 0, -25. We got 5, 0. I'm going to pick 4. So if x is 4, then we're going to have y is 4 squared minus 25, or 16 minus 25, which is -9. So somewhere right here at 4, -9. And then there's going to be a matching one right on the other side. It's symmetric. So it'll be the same height, which is at -9, and it will be the same distance on the other side of the axis of symmetry. So it'll be -4, -9. Domain in this case is all real numbers, because the graph goes as far left or far right as we want. Remember, domain's about the x values. Range has a lowest point, which is -25. So it's all y values bigger than or equal to -25. Remember, range is how low to how high. Increasing, looking at the x values, and decreasing, looking at the x values. As I trace this from left to right, it first drops down, so it's decreasing when x is less than 0, so the first half of it, and then the second half is when it's increasing when x is greater than 0. And we've got everything filled out here. Alright. On to number 5. Number 5 is in standard form. We can factor out the negative and get x squared minus 4. And x squared minus 4 is the difference of two squares, so we got -x plus 2 times x minus 2. Also, we can grab the y-intercept here, plug in 0 for x, and we end up with 4 for y. So 0, 4. I'm going to write factored form over here. And find the roots by setting y equal to 0 and solving. And I take my factors that have x and set them equal to 0. And I get x is -2 and x is +2. So roots are x equals -2 and x equals +2. And the roots give you x-intercepts. So -2, 0, and +2, 0. I'm going to go to the graph now because I have some points I could work with. Plot those points. Label the points. And we see we got the main part of our graph. We see that just from looking at the graph, that the y-intercept is the vertex in this case. That will not always be the case, but with these three problems that we've just gone over, that is the case. Line of symmetry is, I'm sorry, I wrote the vertex wrong. I mixed up the 4 and the 0. Let me fix that. Line of symmetry is going to be x equals 0 because the line of symmetry is what cuts this parabola in half, and it's cutting right down the middle here at x equals 0. And vertex form. Well, I'm looking over in standard form at what a is. A is -1. And so I get y equals -1, x minus, now h is your x value in the vertex, and k is the y value in the vertex, so x minus 0 squared plus 4. And that would be vertex form. You can simplify that a little bit further down to y equals -x squared plus 4. That's also vertex form. It's important that you know that those are both the same thing. And in this case, again, the vertex form and the standard form are the same. We want the domain. It goes as far left and right as we want, so it's all real numbers. The range has a highest point at 4. I'm looking at the y values. So it's all y values less than or equal to 4. As I trace this graph from left to right, it's increasing when x is less than 0, and it's decreasing when x is greater than 0. And then I want 5 points here. So we got -2, 0. We have 4, 0. We have +2, 0. And let's find a couple more points. So if I let x equal 1, I'm going to get y is -1 squared plus 4, which is -1 plus 4, which is 3. So 1, 1, 3. And again, I'm noticing I made a mistake. I put 4, 0. It should be 0, 4. Sorry. Alright, so I'm going to plot 1, 3 right there. Label it. Use symmetry to quickly get the other point on the other side, same height. And then the x value is the same distance from the center as the first x value, so -1, 3. And we finished and completed that table. Again, on this page, notice there's 3 questions at the bottom. Those questions need to be answered. They're part of your homework. So hopefully you answered this. How are the vertex and the line of symmetry alike, and how are they different? So how are they alike? They have the same x value. How are they different? The vertex is a point. The line of symmetry is a line. Alright, second question. Explain how to find the line of symmetry of a parabola if you know two distinct x-intercepts. Say my x-intercepts are x1, 0 and x2, 0, then my axis of symmetry is going to be the line x equals, you take your x1 plus your x2, your two x-intercepts, add them and divide by 2. So you average the x-intercepts to find the axis of symmetry. Or the line of symmetry. Alright, last thing here is to look back at 1 through 6 and answer what is the relationship between the x-intercepts, or roots and zeros, and the factored form. And what you'll notice is factored form, not always, but you can always write factored form this way. Factored form is a times x minus your root times x minus another root. Let me explain. Let's go look back here. So on number 5, my roots were -2 and 2. And so if you have your roots in a, so if I said, okay, my root is x equals -2 and my root is 2, and I tell you that a, in that case, number 5, a was -1. So factored form would be y equals, but a, and then x minus -2 and x minus 2. So it's x minus your root. So my -2 went there, my 2 went there, and double negatives make a positive. So this is y equals -1 x plus 2 times x minus 2. So that's nice to know. If you know the roots, you can easily write factored form, and that will come into play later on to know that relationship. Number 4, think about number 4 here. Let's assume all we knew were the zeros here, and we knew that a was 1. Then factored form would be y equals 1, x minus -5, that's the -5 there, times x minus 5, that's that 5 right there. And so that would be y equals 1 times x plus 5 times x minus 5, and I got factored form quickly from the zeros. Again, it's a good relationship to see. It will help you out to understand this. Again, number 2, you could see the same thing. If I took my roots, gotta know what a is. A is -1, and then my factors are always x minus your root. So my root is -3, so my factor is x plus 3. My root is 3, so then my factor would be x minus 3. Right? And then a was negative 1, and there's your factored form. And that is the end of that homework. Hope things are going well for you guys. Miss ya. Hope you're making the best of the situation, and I'll see you later.